Hello, blocks 1, 2, and 4, geometry students. Peace and God's presence and protection and all of His goodness be with you as we look at this, another practice quiz. I'm going to do not all the questions, but just a few with you. Of course, I'm going to start with this one, being number 1. There's a verse spoken by Jesus Himself, which informs of limitless abilities God has given to those who believe in Him. So I want you to write this verse, and I trust it will be written on your hearts as well. I'll just say it with you right now because I know you've got it written down, and this is just an attempt to write it even more indelibly on your heart. Say it with me. Most assuredly, I say to you, he who believes in me, the works that I do, he will do also. And greater works than these he will do, because I go to my Father. That's the challenge, but what a good challenge from our Lord. And then the Pythagorean theorem, I'd like it to be well known by you. Maybe not so deeply embedded, but nevertheless, the Pythagorean theorem. And that one is simply this. You've got it, I trust, written down. It says, in a right triangle, remember, this is not a wrong triangle now. Nothing is wrong with this. And it's not a left triangle either. The square of the hypotenuse is equal to the sum of the square of the legs. The squares of the legs. Some people mix this up and they put the square of the sum. Well, it should be the sum of the squares. Please don't reverse these two words. It's the sum of the squares. There's a difference. So say it with me. In a right triangle, not a wrong triangle now, the square of the hypotenuse is equal to the sum of the squares of the legs. And the formula for the Pythagorean theorem, as you know, is a squared plus b squared equals c squared, where c is the hypotenuse. So that's why the hypotenuse is equal to the sum of the squares of the legs. This is the formula. When I say state, I want all words. No symbols here, no letters. All words for the statement. But the formula, certainly you can put letters for the formula. And here's where we apply it. For each of the triangles shown, find x. So here we look at it and we see it's a righteous triangle. So we say, okay, since I have two side lengths and I'm missing only one, I can find it by using or employing the Pythagorean theorem. In a right triangle, whenever you've got two lengths, you can always find the missing one. If you only had one, let's say we didn't know this was 12, we only had one length, we would have difficulty finding the missing one. But whenever you have two, you can find the missing one. And now it's important to identify the hypotenuse. Is it going to be 12, 16, or x? The hypotenuse is always the longest side of the triangle, and this is the one opposite the largest angle. So the hypotenuse here is x, and that is squared. It's equal to 12 squared plus 16 squared. 12 squared, you know, is 144. 16 squared, you might not know, but it's 256. We add those together. 6 plus 4 will give us 10. Carry a 1. 5 plus 4 is 9 plus 1 is 10. Carry another 1. 2 plus 1 is 3 plus 1 is 4. So we have x squared equals 400. You know how to find x from this? X would simply be the square root of 400, which is a number when multiplied by itself gives you 400. So that number would be 20. How about this one, number 4? Here we have we're given 2 of the lengths. We can certainly find the missing one by again using the Pythagorean theorem in formula format like this. Now here we have to look carefully to find the hypotenuse. Is it x? Is it 12 or 13? It's always going to be the one, longest one, the one across from or opposite to the right angle. So 13 goes here. You can see this is different because in this one the x squared was x was the hypotenuse. So watch this carefully, because this is a different look at the using the Pythagorean theorem. A squared plus b squared now is going to be x squared plus 12 squared. So these are the legs now. X squared plus 12 squared. 13 squared 169. 12 squared is 144. And do you remember how to find x from this? To get this x squared term by itself, we subtract 144 from both sides. When we do, we get 9 take away 4 is 5, and 6 take away 4 is 2. That's equal to x squared. By the symmetric property, I can switch these and get x squared on the left and 25 on the right. And then the last step would be to say x is equal to the square root of 25, which is going to be 5. I trust that will help you. And now to similarity of polygons. Complete the following for number 5. 2 polygons are similar if 2 conditions are met. One of them is that corresponding angles have got to be congruent, like you'll see here. The angle S is congruent to angle L. Angle A and angle O are congruent, and they're matching because both of them have got double arcs. Angle V, although the 3 arcs are not shown here, is congruent to angle R with the 3 arcs, and finally angle E with 4 arcs are congruent to angle D. So corresponding angles are congruent. In addition, the ratios of corresponding sides. These ratios are equal. Example, 3 over 9 is the same as 5 over 15, the same as 5 over 15, same as 4 over 12. Okay, these are all matching sides, and if you work any of them out, let's say we take the 5 here over the 15, that would give us 1 over 3. That's where we're coming now. The scale factor here is 1 over 3. Let me just abbreviate like that for the scale factor. The scale factor is important because once you know the scale factor, then you can find any missing side. So I'm going a little bit ahead of myself here because here it says write a statement of similarity, which I didn't write it, but I did find the scale factor as I go from the smaller quadrilateral to the bigger one. Now here, statement of similarity is simple. It's going to be Let's say A, V, E, S is similar to, we're going to have to start with the one with the double and work through the triple and then the quadruple and end up with the single. So it's going to be O, R, D, L. But that's not the only way of doing it. That's just one way. You can do it other ways as well. Okay? Now, given that triangle ABC is similar to triangle DEF, find the value of x. And this is a very, very classic, very common similarity problem. The first thing to do, the very first thing to do is to find the scale factor. Once you find the scale factor, you can find any missing length. So let's go ahead and find the scale factor. We find it by making a ratio of two known matching lengths. So if I do this one, I'm going to call this A, B, C, and then D, E, F. F is down here. You can't see it. But let's make a ratio of two known matching lengths. We have 10, which is AB. AB matches with DE. So it's 10 over 15. The lowest terms, that's going to be 2/3. So that's a scale factor right here, 2/3. Now we can use the scale factor to find the x. Here it comes. The x belongs to the smaller of the two triangles. So I can do x over, x is AC. So AC first and third will correspond to DF. DF is 15. Sorry, 42. And that's going to be equal to either 2/3 or 3/2. What do you think? I hope you said 2/3 like this. Why? Because x is in the numerator and x is the smaller of these two. X comes from the smaller figure. So x over 42 is equal to 2/3. And with the cross multiplication, we get 3 times x is equal to 2 times 82. 3 times x equals 2 times, not 82, but 42, sorry. All right, let's work it out. 3x equals 2 times 2 is 4, and 2 times 4 is 8, 84. When we divide that out, we get 3 goes into 8 twice. That's 2 times 3 is 6. Subtract. Bring down a 2, and then bring down a 4, rather. 3 goes into 24 8 times. So our x here would be 28 for that one. All right. I think this takes us pretty close to the end. You can just look at the one. The one I gave you is not like this. But may God bless you and guide you, and look forward to seeing each one of you soon. Bye-bye.